Okay, so question number 1 is asking to find the determinant of these matrices. So the first one is easy because it's 2 by 2. So all you have to do is take the right diagonal, 5 minus 4, which is 20, and then the wrong diagonal, negative 10 times negative 2 is positive 20. So 20 minus 20 is 0. That means our matrix is singular. For the next one, we have the wrong diagonal. So since it's a triangular matrix, a wrong triangular matrix, but its determinant is still the diagonal, multiples of the diagonal. So determinant is 3 times negative 1 times none times negative 1. So previously I said when you have the wrong diagonal, multiply by negative 1. But after when I checked this one, I found out that actually it's not true for everyone. You do not change sign. Do not change sign if your matrix has 4 by 4 dimension or 4 by 4 plus 1 dimension. What does it mean? It means if you have a 4 by 4 matrix, do not change the sign. If you have the multiples of 4, means 4 times 2, 8. If you have 8 by 8, do not change. If you have multiples of another 4, 12. If it's 12 by 12, so 4, 8, 12, 16. If you have that dimension, then do not change. And what does 4 by 4 plus 1 means? It means 4 plus 1. So when you have a 5 by 5 matrix, do not change. So you have 8 plus 1. If you have 9 by 4, so sorry, my bad. I should have said n times 4 by 4 plus 1. It means a multiples of 4 plus 1. So all the multiples of 4 do not change. And then multiples of 4 plus 1, like 5, 9, 13, 17. If you have these dimensions, do not change. So even if you did change in this exam, I didn't punish you because it was my fault. So the correct answer is positive 27. But if you followed my method, it was negative 27. So all I did was cross out the negative. And since it's not 0, so this is not singular. And people.
On our end, it says -3 at the third one.
It's not actually negative, it's the brackets. But if you had the right number 27 with either sign plus or minus, it was fine. But if you're completely different numbers, then I took up points. Then for C, we have so many zeros. So we are going to use inspection, where we are going to use cofactor. So first of all, in 4 by 4, we have too many zeros here. So we can expand around either fourth row or the first column. Either one of them is fine. If you do it around first column, then you're not going, never mind. If you use first column, then you're not going to use the first column or the second row. And if you want to use the fourth row, then you're going to use 4, and you're not going to use either fourth row or fourth column. It's up to you which one you want to use. But whichever row, whichever column has the most zeros, pick that one first. So if I pick 5, I have to look at the position. Plus, minus, plus, minus, plus, minus, plus. So our 5 is positive. So our determinant is 5 times. Now in the next 3 by 3, this one has most zeros. So we are going to expand around the first column. That means we are going to keep 1, but we are not going to use row 1, column 1, or row 2. Because column 1, row 2 has the 1 that we are going to use. And as a position for this one, so if this one is plus, this one is minus. So we have a -1 here. And now we are going to get the determinant for the next 2 by 2. So this is our 2 by 2. The right diagonal is 2 times 3, 6. And we are subtracting the wrong one, 2 times 1, 2.
So if you just like got rid of like the 5, I mean just put cancel the 5, so it's a 3 by 3, and then you do like the 3 by 3, and then you add like the 2 extra rows. You did it that way, like it's possible as well.
No, because we have a 4 by 4.
Yeah, so you get rid of the.
Oh, you mean once you are done with 4 by 4, the remaining 3 by 3? Yes. So we get 5 times -1, which is -5, and then 6 times 2 is 20. Sorry, 6 minus 2 is 4. So we get -20. And so it's non-singular. Any question? Now for the next one, I took up points from many of you because you did not follow the direction. Gibran, your exam. So we have the equation ax plus b equals c. So x is on the right side. So if you want, you can subtract ax from both sides. So we get matrix B equals x minus ax. Since our x is on the right, so if you want to pull out as a common factor, you have to do it on the right side. You cannot do it from the left, you have to do it from the right. So you get identity minus a equals b. You may wonder, why does it matter? I can pull it from the left. Does it matter? Well, it does matter, because if you pull out from the right, then your I minus a is on the left. So you're going to multiply I minus a inverse on the left side, on both sides. I minus a inverse. So inverse and that cancel out, and you get x equals I minus a inverse times b. Now, I said many times, matrix AB is not equals matrix BA. Multiplication is not commutative. You cannot switch their position. So if you do B times that, you shouldn't get the same answer as that times B. Well, in this case, you got the same answer. That's only because I gave you B matrix is a symmetric matrix. For symmetric matrix, it doesn't matter which one you multiply, you got the same result. But if it wasn't a symmetric matrix, I would have given 0 to everyone. But since it was symmetric, I only took off 1 point for your mistake. Then you find the inverse, multiply by b, whatever you have, that's the answer. So I will post the solution. Since this will not be in the exam, I'm going to just give you the answer here. The answer X matrix is 0, -2, -2, 2. And the solution, you can look at all the details, how to find A inverse, the I minus A inverse. So this will not be in the exam, in the final exam, but this will be in the final exam. The next one, find inverse. So for this inverse, I'm going to ask you to, I'll give you a bunch of system of equations. And then I'll ask you first thing, rewrite this as X equals B. And then the second thing, solve for X using the inverse matrix. So that time, you need to find the inverse of 3×3 matrix. In the final exam, I'm talking about. Now here, I just give you the matrix, and you have to find inverse. So many of you try to use reduced echelon form to find the inverse, and then you got completely wrong. Reduced echelon is okay, but if you don't know, if you're not strong enough with your reduced echelon form, then this is not for you. You have to use either cofactor expansion method or the method I show in class, the weird method. So I like to use the weird method because this is shortcut and easier. So in this weird method, I'm going to rewrite the first column. So 1, 2, 3, 0, 1, 2 to find the determinant. So determinant of A. We'll take all the diagonals. 2 times 1 is 2. The next diagonal is 0. And the next diagonal is 2 times 2, 4. And then we subtract. Let's change the color. This diagonal, 3 times 1 times 1, which is 3. The next diagonal, 2 times 1 is 2. And then the next one is 0. So we get 2 cancel out. 4 minus 3 is 1. So determinant is 1. And now the A inverse is 1 over determinant of this new matrix. Now in this new matrix, it is this. We need to rewrite the first 2 row and first 2 column. So 1, 0, 1, 1, 0, and then 2, 1, 1, 2, 1. Once you rewrite first 2 row and first 2 column, then you're going to cancel out the entire first row and entire first column. And then you're going to multiply every 2×2 or chain of 1. So first 2×2 is here. 2 times 1, 2, minus 2 times 1, 2. I'm going to go column wise, but the answer I'll be right row wise. I'll be writing them row wise. So the next 2×2 is 2 times 1, 2, minus 2 times 0, which is 0. The next one we have 1 times 0 is 0, minus 1 times 1 is 1. So our first column is done, means in our inverse matrix, first row is done. Now the next one, I'll pick this. We have 3 times 1, 3, minus 2 times 2, 4. Then we have 2 times 1, 2, minus 3 times 1, 3. Lastly, we have 1 times 2, 2, minus 1 times 1, 1. So every 2×2, multiply, get the determinant and write them in the opposite direction. Then let me pick red. We have last one, 2 times 2, 4, minus 3 times 1, 3. And then we have 3 times 0 is 0, minus 2 times 1 is 2. Lastly, we have 1 times 1 is 1, and then 2 times 0 is 0. So this is the inverse. Since our determinant is 1, so this is only 1. And then we write all the sum here. We have 0, negative 1, 1. We have 2, negative 1, negative 2. We have negative 1, 1, 1. Zero, negative 1, 1, 2, negative 1, negative 2, negative 1, 1, 1. So this is our A inverse. If you use this method, you only need small space.
We have to find inverse of 4 by 2.
It's too much. 4 by 4. Any question on this? So this will be in the final. And to solve your X matrix, you multiply this with the B matrix. So I'm going to give you a B matrix here, the coefficient matrix, not the coefficient, sorry, the constant matrix. You multiply inverse by the constant matrix, something, something, something. And then you do matrix multiplication and you get your X1, X2, X3. So this is you're going to do in the final, not here, in the final. In the final, there will be also LU, one LU factorization. So in your note, if you want, you can write down the shape for the L and shape for the U. So our goal is to convert this A matrix into U matrix, which has same first line as the A, original A. So 1, 3, 2. U means upper matrix. So everything here will be 0. So you need 1 space, 2 space, 3 space. You need to just find 3 spots in upper matrix and your L matrix, lower matrix. So it has diagonal 1. Everything above the diagonal is 0. So you need 1, 2, 3 position. So fill out this L and U and you have your results. So if you compare A matrix with the U matrix, our first position is 1, first position is 1, so you're happy with the first position. In A matrix, our second position is 2, but in the U matrix, our second position is 0. That means we need to convert these 2 into 0. So we do the row operation. We are going to change row 2. So our new row 2 will be current row 2 minus twice row 1. And then in the U matrix, the third position in the column is 0. But in our A matrix, the third position is -3. So we need to convert this -3 into 0. That means we are going to change row 3. So the new row 3 will be current row 3 plus 3 times row 1. So let's do all these operations. Our row 2 is 2, 7, -5. Twice row 1 is 2, 6, 4. Point is subtract. They change their sign. So we get 0, 1, -9. And for the third row, our current third row is -3, -8, 6. We are multiplying row 1 by 3. So 3 times 1, 3, 3 times 3, 9, 3 times 2, 6. And we are going to add them because our first row is already negative. So this cancel out, we get 0, 1, 12. So in U, we have 1, 3, 2. And then we have 0, 1, -9. And we have 0, 1, 12. Now the L matrix. So first we did -2. We multiplied by -2 the row 1. So in this position, we are going to change the sign and put the number. So here we subtracted, here we did -2 times R1. So that position for L would be +2. And then to get rid of this third position, we multiplied by +3. So we're going to change sign and we're going to put -3 in this position. So whatever operation you do to change the position for U, the same exact coefficient will put in the L matrix. So U matrix is almost done. The only thing we need now is make this to be 0. That means we are going to change our row 3. Let me write here. So the new row 3 will be current row 3 minus row 2. So this one is easy. We don't need anything. So our U is, let me erase this, is 1, 0, 0, 3, 2, 1, -9. If you subtract row 2 from row 3, so 1 minus 1 is 0, and 12 minus -9 is 21. And this is our U matrix. So to change this position, we basically did multiply by -1. So we're going to change the sign and put it here as a +1. So L matrix is that L is 1, 0, 0, 2, 1, 0, -3, 1, 0. And our U is that. Now in the second part, I said, well, how do you know whether you are right or wrong? So let's multiply L with the U and see if you have A matrix as their product. So you multiply the first row and first column, then first row, second column, first row, third column. And then you do second row, first column, second column, third column. And then the third row, first column, second column, third column. You really should multiply to see whether that will give you A or not. If it doesn't, that means something is wrong. So go back and check carefully. Any question? The next one I will not put as a big question. It will be 1-point question. So all you have to do is figure out whether it's a subspace or not. You didn't have to prove anything much. Most likely it will be not a subspace so that you can see. For example, this one. It's clearly not a subspace because the 0 matrix is not in here. If x1 is 0, x2 is 0, and x3 is 0, the answer is not 5. So that tells us that 0 is not in the set. And if it's 0 is not in, so it's V. 0 is not in V in this set. So this is not a subspace. So for final exam, all you have to do is show which one fails, and then you're fine. I'm going to skip that one since this will not be in the final exam. I'm going to post the solution, okay? So you can check the solution, whatever I'm skipping. Now the null space, there will be one null space in the final. And to find null space, you need to solve for the homogeneous system of equations. The goal is to convert this into reduced rational form. So our 1 is fine, we don't mind, but we want this 2 to be 0. That means we're going to change row 2. So our new row 2 will be current row 2 minus twice row 1. So our current row 2 is 2, 5, 5, 6. Twice row 1 is 2, 4, 6, 8. And when you subtract, they change their sign. So you get 0, 1, -1, -2. So we have 1, 2, 3, 4, 0, 1, -1, -2. Now, since we have these two positions on the top and bottom, so we can actually change the top one using the bottom one, or the bottom one using the top. No, we can change the top one using the bottom one. Yeah. So we can change these 3 into 0. So if you change row 1, our current row 1 will be our new row 1 will be current row 1 plus 3 times row 2. Because 3 times -1 is -3. If you add them, the answer is 0. So we get row 1 is 1, 2, 3, 4. 3 times row 2 is 0, 3, -3, -6. When you add them, we get 1, 5, 0, -2. So 1, 5, 0, -2, 0, 1, -1, -2. You can reduce more, but you don't have to if you just solve using backward. It is back substitution, so we have 0, 0 here. And right. And then from here you see this is x1, x2, x3, x4. So the first line is telling us x1 plus 5x2, x3 is not there, minus 2x4 equals 0. So if you solve for x1, our x1 is -5x2, positive 2x4. This information, the second line is telling us 1x2 minus 1x3 minus 2x4 is equal to 0. So if you solve for x2, it's x3 minus plus 2x4. So we have x3, x4, x5. There is no equation for them. So x3 is itself, x4 is itself, and also x5 is itself. There is no, wait, how do you have x5? Sorry, my head is not working, it's x4. You have 4 variables. Why do you have 5 variables? Sorry about that. So x1 and x2, they have a formula, but x3 and x4, they don't have anything. So they are the free variables. Now, the way I like to do it is write them as matrix so that we can easily see each vector. So x1, x2, x3, x4, x1, x2, x3, x4. So x1 is negative 5x2 and positive 2x4. Negative 5x4, negative 5x2 and positive 2x4, positive 2x4. X2 is 1x3 and 2x4. X3 is itself, so x3 is itself and x4 is itself. So we have this. Whatever is missing here, we fill them out with zeros. So 0, 0, 0, 0, 0. So these three, and also here is another 0. Oh, I did something wrong. What did I do wrong? No. But my math is somewhere wrong. So R1 is R1 plus 3 R2. 1, 2, 3, 4. So if you did this one, let me start at the beginning. 2, 4, 6, 8. And you're subtracting. So 0, 1, -1, and then 8 minus 6 is -2. So this line is correct. Now from here, we have R1 and then 3 times R2. So 0, 3, -3, and -6, right? 0, 3, -3, 6. 0, 3, -3, -6. So we have 1, 5, 0, -2. 1, 0, 5. 1, 0, 5, 8. So x1, 5x2 minus 2x4 is 0. x2 minus x3 minus 2x4 is 0. So x1 is 3 and 4. Oh, here. This x2, we need to fill out with this. Because x2 has the equation. So if you use this, then fill that out. So let me complete this first. So let me erase this one now. Our x1 is -5 x2, but x2 is x3 plus 2x4. Plus 2x4. So we distribute, we get -5 x3, -10 x4 plus 2 x4. So we can combine this x4, we get 5 x3 minus 8 x4. So x1 here is 5 x3 minus 8 x4. So x1 is 5 and -8. x2 is 1 and 2. x3 is itself and x4 is itself. So we are missing one spot here and one spot there. So these are our vectors. So our null space, null of A, is a span. I don't have space, so let me write it down. It says span of these two vectors, 5, 1. Sorry, this is negative. -5, 1, 1, 0. And our second vector is this one, -8, 2, 0, 1. because these are the only two vectors. They have non-zero entries, only two columns. Since we have two, so our nullity, which is the dimension of your null space, is 2. Question? Even though it's only 2 by 4, it should be easier, but actually we have something more complicated. Actually, things would have been much easier if you get rid of this 5 instead of the other 3 and 4.
It's 3 and 4 pretty good. So in the second transformation, could you solve for like row 1 equals row 1 plus 2 row 2? And then have
Here?
Yeah, then have the x4 be 0 in the first row. Answer.
Here? We can do that. So you can get rid of 3, 4, or 2. Any one of them you can get rid of. Whichever is the correct one will be actually get rid of 2. So I don't have to resubstitute. If you try to do 3 and 4, x2 or x4, then you're going to resubstitute. Like here I resubstituted, so you have to resubstitute to simplify the other one. But if you have only one x1 and only one x2, then you don't have to resubstitute because x1 and x2, they both depend on x3 and x4. Same answer. It doesn't matter which method you do, the answer is supposed to be same. If you don't get the same, something is wrong. Like me before, I substituted and I found 3 of them, but the actual solution has 2 of them. So I've realized that something is wrong. So I checked, oh, my substitution needs to be resubstituted, my x2. That's why we will do 3 by 3. But the difference in 3 by 3 is that all the results x1, x2, x3 turn out to be 0, 0, 0. This is the answer for this one. Now, when you have 0, 0, 0, 0, 0, 0 is a 0 vector. So it's not actually a non-zero vector. So we don't count non-zero vector. So for nullity, the dimension, we may think all our nullity is 1 because we have 1 vector there, but actually the nullity is 0. Means it doesn't have any dimension. It's 0 by 0 because we have our null space is consist of only 0 vector. So our null space is the span of 0, 0, 0. But this is not a non-zero vector. Null space means non-zero vectors. Okay. So how many non-zero vectors you have in your null space? That's the nullity. We don't have any non-zero vectors. So that's why nullity should be 0, not 1. But if you got it correct and then tell me nullity is 1, I give you point because you don't know, you don't have this knowledge. So it's fine. Now, there'll be 1 or 2 from this example. So when you have more vectors than your space, vector space, definitely one of them is dependent. You may not see it, but it's dependent. So one of them has to be dependent. Usually, the third one is dependent. Usually, not always, usually. That means you just have to compare 1, 3 with 1, 1. So you see, if you multiply 1, 3 by something, do you get 1, 1? Is it possible to multiply 1, 3 by something and you get 1, 1? Not possible. That means these two are independent. So we have 2 linearly independent vectors. So question number 1 says, are they independent? No, because we have three vectors in R2. One of them has to be dependent. Well, then how many independent? We have two. How do you know? Because one is not a multiple of the other one. Anytime you have two vectors, that's how you check. Is one a multiple of the other one? Shibu? R2 cannot have three independent vectors. That's the answer for one. Are they independent? No. Why? Because R2 cannot have three independent vectors. So how many? For how many you need to show what? One is not a multiple of the other one. For three are the spanning set. So to be a spanning set, you need at least n many independent vectors in Rn space. So we have two independent vectors in R2. That means yes, this is a spanning set. So what's the dimension of the span? It means how many linearly independent vectors you have. We have two. So the answer for 4 is 2. The next one is asking for geometric shape. If you have two independent vectors, our shape is a 2D plane that goes through the origin. And the last one, in order to form the basis, we need exactly n linearly independent vector in Rn. So we had two, but we need exactly two. We don't have exactly two. We have three of them in our set, so it's not. When you have three vectors, your step one always should be look at the determinant. If the determinant is not 0, then V1, V2, V3 are linearly independent. So if you find the determinant actually is not 0. That means for 1, they are linearly independent, all of them. So we have 3 linearly independent. And then for spanning set, we have 3 vectors in R3. So yes, they span the entire vector space. What's the question for? The dimension of the span? we have three vectors. So we have dimension 3. And then 1, 2, 3, 4, 5. The geometric shape for 3 independent vector is a 3D plane that goes through the origin. And since we have exactly 3 independent vectors in R3, so yes, they form a basis for the vector space. So since we know R3 can have, go ahead, Shivu.
So the span,
Mhm.
we check if there's
At least n many independent vector in Rn.
for the span getting exact.
No, for basis, we need exact. Basis is exactly, span is at least. So the next one has 4 vectors in R3. Definitely, all of them are not independent. So for question 1, the answer is no. Not all can be independent. One of them definitely will be dependent. We don't know which one. So you cancel out one of them. And then you find the determinant for the other 3. So determinant of -4, 5, 2, -1, 2, 1, 3, -2, 0. If the determinant is 0, then you cancel out another one, and then you find the determinant for the other 3. As long as one of the 3 PR gives you determinant not 0, then you have 3 independent vectors. So this one has actually 3 independent vectors. So they're asking how many independent vectors we have. We have 3. Since you have 3 independent vectors, so yes, they span the entire set, entire vector space. And then the dimension of the span means how many independent vectors? We have 3 independent vectors. So what's the geometric shape? Same as this one, 3D plane that goes to the origin. And then for basis, 4 vectors cannot form a basis for R3. So no, we need exactly 3, but we have more than 3. So you cannot form a basis. And the last one,
Sorry, if the determinant is not scalar.
then they are linearly independent. So the next one, if you look at closely, so we have V1, V2, V3, V4. V3 is actually 4 times V1. And V4 is actually 3 times V1. So that means V3 and V4, they are dependent. So they don't count. So you have 2 vectors, V1 and V2. So if you multiply V1 with something, do you get V2? If you want to multiply, if you want to get from 1 to 3, you need to multiply V1 by 3. But if you do that, every element in V2 should be a multiples of V1, but it's not. So V1 and V2, they are not multiple of one another. That means we have 2 independent vectors. So for 1, they are not independent, and we have 2 independent vectors. Since we have 2 independent vectors in R4, what's the question? At the spanning set. So of course, they do not span the entire space. We don't have enough vectors to span the entire space. So no. Dimension of the span means how many independent vectors we have? We have 2 independent vectors. Since we have 2 independent vectors, the shape is 2D plane. And definitely they do not form a basis. We need 4 independent vectors in R4. We don't. So the main thing in this type of questions is first figure out how many independent vectors you have. Based on that, all the answers you can answer easily. All the questions you can answer easily. So any question on this? Shivu?
So you cancel the ones that are,
The dependent is useless. We don't need them.
and then.
And then whatever, and you cannot find the determinant because it's only determinant exists only for square matrix. Anytime you have two vectors, all you have to do is see if one is a multiples of the other one. That's all you have to do for two vectors. If you have three vectors, then you need determinant. And in this class, for four vectors, we're not going to ask for determinant because it's too much. So definitely they will be dependent. You just have to find out how many.
Like the neural vector space for
Null space.
like the neural
You're talking about subspace.
like, it looks like two conditions. Like there were,
Linearly, two conditions to be subspace. No, subspace needs three conditions.
Yeah.
And then linear transformation. Linear transformation is two conditions. The scalar multiple and then vector addition.
yeah. So,
Those are for linear transformation. Here we are not doing transformation, we are just observing the vectors we have. Do they span the entire vector space? Do they form that vector space or what? We're just looking at that. So in the final, there will be one or two of these instead of four. And now this one will be in the final. It doesn't matter how many vectors you have. If they're asking, do they span? All you have to do is see if the vector you have, is it a linear combination of the other vectors. So if this is, let's say X, this is Y, and this is Z, suppose. So to see if X is in the span of Y or Z, you need to see if X is a multiple of Y and a linear combination of Y and Z. This is what they're asking. Is X a linear combination of the other two? If yes, then it's in the span. If no, then they're not in the span. So two ways of answer this. Either solve for A and B and see whether they are zero or not. Or all you have to do is, since we have three vectors in R3, just look at the determinant. If the determinant of X, Y, Z is zero, then yes, X is in the span of Y and Z. But if the determinant of X, Y, Z is not zero, that means all three vectors you have, they are independent. So no, X is not in the span of this. So for here, the easy method is just find the determinant. If you find the determinant, your life is easy. So you can write down this information in your formula sheet, that the vectors are independent if the determinant is not zero.
what is it for this one?
This is independent. So if you look at the determinant of 1, 2, 3, 3, 4, 2, negative 1, 2, 3, the determinant is what? Let me see. 3. No, not 3, sorry. 20, no, 16. The determinant is 16. So the answer is no. It's not in the span of the other two. That means the B. If it's not in the span of the other two, then what's the dimension of your span? Well, dimension of the span of these three vectors, all three are independent. So what's the dimension? 3. So dimension means how many independent vectors you have.
For X, I don't know.
What do you mean for X up and down?
But no. But X on.
Show me after class. Maybe I made a mistake. So yeah, it's not, determinant is not 0, means no. X is not a combination of the Y and Z. But this will not be in the exam. So I'm not going to go over this, but like before, almost no one got this correct. So I wrote the detailed solution in the solution, which I'm going to post tonight. But let me go over this one. So most of you got this one correct because you know, singular, non-singular means determinant. So non-singular means determinant cannot be 0. So all you have to do is find the determinant using whatever method you know, and then see what makes the determinant 0. So here, when you solve, the determinant is 2, right? 2 or -2. The determinant is 2. Determinant is 2. That means in order to be non-singular, you can use C equals anything, any number besides 2. Because when X is 2, the matrix becomes singular, means bad. But they're asking what value of C will make this matrix good. So if you just say determinant is 2, so C is 2, this is wrong. C equals 2 makes the matrix bad, but the question is tricky. They're asking what will make this matrix good, not bad. So be very careful about the direction, okay? Find the basis. Yes, it will be a short question answer. Find the basis. So it doesn't matter how many vectors you have. All you have to do is look for one independent vector. If you see one independent vector, that's your basis. So here, if you look at x2 is, if you compare with x1, it's twice x1. If you look at x3 and compare that with x1, it's 3 times x1. That means x2 is dependent, x3 is dependent. So we have one independent vector x1. So our basis is x1. Now in the exam, I'm not going to give you 3, I'm going to give you 5 or 6. Okay? But all you have to do is look for one vector that doesn't have any connection with the other vectors. And that one vector will be your answer. You may see multiple of them, but they're asking to find one of them. So just write one of them. So you're not doing any math, okay? You're just observing and see if they have a connection or not. C equals any number besides 2. Because when you have 2, that will make your matrix singular besides 2. Alexander, question? No.
Oh, not even 10B.
10A will not be, but 10B will. So for 10B, remember, no math is needed. All you have to do is look for one independent vector and you are fine. And also, I'm going to give similar to this type of questions. True, false, yes, no, fill in the blank. Okay. Here, this one. So let's say you have an even function, x squared, and you have an add function. No, it's a 2 even function. Let's say we have one even function, x1, and another even function, negative x squared. So if you add them, you get 0. 0 is even or add both of them. So it's definitely not even. So it's not. The answer is not, because if one even is positive, the other even is negative, your answer could be a positive odd degree. Or something for odd, if one of them is odd, the another of them is negative, odd, they cancel out. So your answer could be even degree power. No, it says or. So if you look at all the even function, add the subspace for P4. Or if you look at all even for add function, add the subspace of R4. So what I use here is the sum condition. Sum of two even function is sum. Is this true? No. Sum of two add function has to be add. But is this true? No. So here, in the final exam, if you didn't know that, you are allowed to bring one page, two-sided formula sheet. You can use any formula, you can write any notes, anything, but do not put any example. If I see examples, I'm going to take it from you and you cannot use it, okay? And I'm going to check one by one your formula sheet. So your final exam is day after tomorrow, 5:20 here. You bring one page, a formula sheet, and your calculator. Don't forget your calculator. Anything is fine, whatever is convenient for you.
You said there's not going to be any 4x4 determinants matrices?
No, determinant will be there, but not the inverse.
Not inverse for 4x4.
But the determinant will be there. And for determinant, make sure you remember the rules, all the rules. Like if you have one row or column of 0, then determinant is 0.
Okay.
Then if you have two same row or two same column, then the determinant is 0. And the other inspection method.
Thank you so much. Have a good night.
I started
Good
writing a
times.
sheet for Maisha. So, do you want me to, take a picture of it and send it to you, so you can check that it's okay?
I trust you, say so.
All right.
But are you sure Maisha can use it? Like, how can she read it, or how can she?
You can,
use it?
Maybe I will have to know when it applies to the problem.
So you'll be with her.
Yes, I'm scribing.
Yeah. So as long as you know what's going on, it's fine for her, right? Because you can read it to her for any
Yes,
questions.
yes,
Also, you can write down all the steps you need. So there will be eigenvalue, like, did you watch the last recording?
yes,
So you know what will be in the exam, right? So I only went over exam 2, but we still have exam 1 materials and also the third part of the final exam.
the eigenvalues and eigenvectors and eigenspace.
So write down all the information, all the steps to do anything. So when she see any question, ask her, step 1 is do this, step 2 is do this. But she doesn't have to remember anything, like memorize anything. Just read
Yeah.
all the steps to her. And then tell her to like, I'll try to give easy questions so that she can do the calculation in her mind. In the last 2 exam, I gave her the exam, same exam as the others, and it wasn't good. So I have to make it easy exam for her, so that she can do the calculation in her head.
Okay, okay,
So I'll try doing that.
okay, thank you.
And thank you so much. It was nice
Thank you.
having you in my class.
Thank you very much.
Aside
I'll-
from writing the formula in the cheat sheet,
You can write down all the steps to solve anything, but do not put any examples.
is definitions?
Definition is fine. Definition, steps, formulas, anything you need to solve anything. I already gave you the exam, right? This will be in the exam. So you already know what will be in the exam. So write down the steps for every question so that you can know how to solve anything.
Thank you.
So could I do something like this for them, for LU factorization? I could do elementary and then ABC and then,
All right. And then like the way I do, like these parts need to be filled out. So
okay, sounds good. Thank you.
Shane. Did I make a mistake reading your exam?
No, I'm just curious about what you, but you said we can have steps and definitions as well.
You can have anything. So from exam 1, this one. So question 1. Then this one. So this is second question. Yes. This one, question 3. And here it says only find the A inverse, but in the final exam, you're going to solve for X. So your X will be A inverse times B. And I'm going to give you 2 of these, actually, 3 and 4. 2 of these, And one of them you're going to really solve it. And one of them will be something like this where you cannot solve it. So all you have to do is rewrite as AX equals B, and then tell me A is not square. So we cannot find the inverse, so we cannot solve it. Okay. So I want to check your knowledge whether you can remember that square matrix doesn't have inverse.
Don't have any,
Yeah. So,
only square matrix is that.
oh, sorry. What I'm saying. Square one. Exam one. From exam one review sheet, what will be in the final exam? So only square matrix have inverse. So it's not square, it doesn't have inverse. And then from question 6 and 7, you need to know how to find square or cube or power anytime. Like anything like this, like how to find the power of a matrix, how to find transpose of a matrix.
But our matrix, you just have to multiply the matrix.
Multiply the same matrix power many times. So it's not powering each element, it multiplying the matrix power many times. So A cube means A times A times A. So multiply 3 times. And then transpose, and then symmetric matrix. So symmetric matrix means A transpose equals to A. So you just need this information. What type of matrix is symmetric? So if this is 4, then this is the 5th one. One of these, where are you going to write the adjacency matrix for the graph? So 5 questions from exam 1 review sheet. Now from exam 2 or exam 2 review sheet. Actually, let me go to exam 2 review sheet. Exam 2 review. From exam 2 review. 1 LU factorization. One determinant with multiple types of matrices like 2 by 2, 3 by 3, 4 by 4. And for this, remember, any rows or column of zeros means determinant 0.
Any factorization is going to be specifically the 3 by 3 matrix.
3 by 3. Any column or any row. And any 2 column or any 2 rows, same means determinant 0. So I'll ask you 2 of these for 2 examples. And then, for example, here, triangular matrix. For triangular matrix, the determinant is their product. And if it's right triangle, like 1, 0, 0, 1, 2, 0, 3, 4, 5. So this is a right triangular. It's just the product. And for 3 by 3, it's this times -1. For right, it's only their product. But, and there's actually no left diagonal. It's wrong diagonal, they told me to tell you. Wrong diagonal and correct diagonal. So this is the correct diagonal, and this is the wrong diagonal. So for wrong diagonal, we need a punishment, so it's -1. And for right diagonal, it's just that diagonal thing.
So
And
for speed, when they have the same row, what the determinant is equal to 0.
same 2 rows or same 2 columns.
And then we have a row of zeros or
A row or a column of zeros.
okay.
So 3 rules, definitely 3 metrics here. And then you'll have 4 by 4, another way, cofactor expansion, like you're going to get 5 zeros. So you just can use cofactor expansion to find the determinant. Find the inverse. This inverse is inside the example I said, x equals A inverse of B. So here you need to find the A inverse. Now all of these will be true, false, yes, no, fill in the blank, those type of questions. So 1 point question. Null space. There will be one null space. So how many questions? One. This is question 2. This is question 3. There will be one 3x3 null space. I mean, I'm not sure 3x3 or not, okay? But one null space. So this is question number 4.
The null space 3x3 won't be on it.
I'm not sure.
No.
I'm still making the exam.
But
So either it could be like type A or type B, but definitely not type C, I think. Type C looks too much.
I couldn't know you when you decide.
I'll try to put something. I mean, the exam one was actually easier, but still many of you didn't get it. So if you don't know what to do, it doesn't matter how easy number I give you, you're not going to do well anyway. Yeah. Yeah, like second exam was pretty easy actually. Really easy question it was. If you see the solution, LU in the second exam. It is really easy, no fraction, nothing. The easy number I give you, but yeah. And for these 6, in the second exam, I gave you 4, but in this exam, probably 1 or 2. Not too many. Find the basis. It will be 1 or 2 point question. So this is type 5. This one is 6. Matrix you ignore. And this one is 7. So instead of giving ABCD, I'll just give you A and B. So how many questions from 1? 5. So 5 and 7. Here, many of them are just small questions. Like you don't need any math. For example, here, find the basis. You don't need any math. To find a basis, all you have to do is look at one of the vector that is independent. And that will be your basis. For example, here, x1 and x2, they are independent of one another. They don't have any connection. However, x3 is a combination of x1. So x3 is not independent. So x3 cannot be your basis. So either x1 or x2, they both are bases. They are saying find one of them, you just write one of them, x1 or x2. So no math is needed, just observation is needed. Okay, so 7, 5, 7, 12. So you already have 12 questions. And now the third exam. The third review, not the exam, sorry. 2 hours. But see, most of them are just true, false, those things. Exam, final exam review. So from final exam review, if I have space, I'm going to give 1 from here, 1 from here. But if I don't have space, then definitely this one, 4.2. No, from 4.1 and 4.2. Either 1 from 4.1, 1 from 4.2, or definitely 4.2. I'll ask you these as small questions. 2 vectors given, find out whether they're orthogonal or not. How do you find that? Find the inner product. If the inner product, if x times x transpose y is 0, then they are not orthogonal. Wait, I forgot. They are orthogonal, right? If the inner product is 0, that means they are orthogonal. So if inner product is not 0, then they are not orthogonal.
So the
What's
so the inner product of
0 means orthogonal. See 0 and this all looks like a 0. So 0 means orthogonal. So how do you find the inner product? Easy. Multiply them element-wise and then add them.
Start there.
That's inner product. 4 times 3 plus 3 times -2 plus 1 times 2. This is the inner product, X transpose Y. So this is not 0, so not orthogonal. So see, easy question. This is true.
Five.
Huh?
Take 5, chat.
Is there like a 2x2 or something for this? No.
No, 3. And then I'll ask one angle between the vectors. Good news, you don't have to memorize the formula. All you need is write down the formula and then follow your steps.
Is it, so for the 5.1, question 5, are X and Y always going to be same side?
Mhm. Otherwise, they cannot multiply.
Yeah.
Hmm.
Would it be
Hmm.
for like more than one column?
Maybe in other book, but in this exam, no. This exam in life is easy, okay? So angle between the vectors. That means you need to write down the angle and then find out how to find each piece of the angle formula. So one of them, question 3. In another question, or maybe in the same question, part 1 will be find angle, part 2 will be find scalar projection, part 3 will be find vector projection, and part 4 will be find verify whether these are orthogonal or not. So, so I'll go over this. So one question with 4 parts. Yeah, each part has different points. And then there will be one here. And you have to use the matrix method. You cannot use your calculus method or algebra method. We can actually solve this using normal algebra, college algebra, or calculus. But here you have to use matrix, otherwise no point. And lastly, one of these, where you're going to find eigenvalue, eigenvector, and eigenspace. 3 things. And I'm still deciding whether I should give you 2 by 2 or 3 by 3. Most likely it will be 3 by 3 because 3 by 3 is the normal one most people use. So how many? 1, 2, 3, 4, 5. 5 questions with multiple parts. You're saying that's crazy, you know. In Baruch, they have 30 questions in the final exam. 30, 30. Okay, so now let's go over all this. I think I have a lecture. So let me see. Lecture for review 3. Yeah, no. Oh man, I don't have it. Lecture, exam 1, exam 2. Lecture, exam 3. Oh man. Yeah. No problem. I just have to make it. Review. Okay, so good news. I posted the solution of this. Did you notice that? I think last night I posted the solution for this review sheet on Brightspace. Definitely this will be in the exam. So let me start with this question. Let's pick this one. No, let's pick this one. So it says find the linear operator, means you are doing the transformation on the same vector space. So since it's in R3, so you're going from R3 to R3. So they gave you the transformation. You're going to write this transformation using a matrix A. So how we are going to find this matrix A? We are going to apply this transformation into the basis, the standard basis. So let me write down the transformation. L of x. The first is 2x to the 2 times x3. The next one is x2 plus 3x1. And then the third one is 2x1 minus x3. So we are going to apply this transformation into L of E1, which is 1, 0, 0. And then we are going to do it on E2, which is 0, 1, 0. And then we are going to apply this on E3, which is 0, 0, 1. Basically, whatever you have written here, all these things follow for these 3 vectors. So first one says our first element is 2 times e with x3. This is our x3. So 2 times x3 is 0. The next one says add x2 and 3 times x1. So this is our x2 and 3 times x1 is 1. Sorry, 3 times x times is 3. Right? 3 times 1 is 3. So 3 times 1.
Why is it 0?
Because this is x1.
Okay.
So this is x1, this is x2, and this is x3.
You're multiplying each line by the number.
By the thing they are telling us to do.
Okay.
So the third one says 2x1, so our x1 is 1, 2x1, and then minus x3, our x3 is 0.
You add these two.
Not add, you simplify them. So 0 is nothing to do 0. The next one is 0 plus 3 is 3. And the next one is 2 minus 0 is 2. So when you apply this transformation on 1, 0, 0, this 1, 0, 0 vector turns into 0, 3, 2.
Is there a reason you have those brackets?
Yeah, brackets. Here I'm actually go back and forth,
Okay.
going back with that, but they mean the same thing. So this is the first column of your A matrix. Then you do the same thing on the second one. This is x1, this is x2, and this is x3. So you do 2 times x3, so 2 times 0. And then x2, which is 0, plus 3 times, sorry, x2 is 1, and our x1 is 0. 2x1 means 2 times 0, minus x3 is also 0. So you get the matrix 0, 1, 0. This is the second column, 0, 1, 0. You do the same thing here, x1, x2, x3, and you get 2x3, so 2 times 1. And then x2 is 0, x1 is 0, and lastly 2x1 means 0, and x3 is 1. So from here we get 2, 0, negative 1. So 2, 0, negative 1. So this is the matrix they are asking us to find. We found it. And then they're asking, once you find your A matrix, verify. Verify that if you multiply A matrix with your X matrix, you're supposed to get the L of X matrix, the transformation. So we have 0, 3, 2, 0, 1, 0, 2, 0, -1. Our x is x1, x2, x3. So you multiply row, column, row, column, row, column. And then it's supposed to get 2x3, x2 plus 3x1, 2x2 minus x3. If you don't get it, then go back in your work and see, did you make any mistake?
A times X equals L of X, that's how you verify your linear.
Whether it's correct or not.
This is the matrix representation.
So this A is a matrix representation, and this is verifying whether your presentation is correct or not.
I remember the group where you have to check for two conditions.
That is for 4.1.
Oh.
So if you have space, then I'm going to put it, otherwise not.
Oh.
Me too, it's much easier. Okay, so one of these. Ethan, what are you doing?
Right.
So remember, in the LU matrix, we verify L times U. If you get A back, then that means L is correct, U is correct. So same thing here. We found the A matrix, but how do you know A matrix is correct? Did you make a mistake or did you found it correctly? So how do you verify? You multiply A matrix with the variable matrix. When you multiply, you're supposed to get your transformation back. For example, here, if you multiply the first row with first column, 0x1, 0x2, and you have 3x3, 2x3 are first element matched. Then you do 3x1, 2x2, 3x1, 2x2, see? Second one is correct. Then you have 2x1 and -1x3, 2x1, -1x3. So my answer is correct. So you already know how to find transpose, the inner product. The inner product determines whether it's orthogonal or not. So write this down in your formula sheet. That if the inner product is 0, then it's orthogonal, otherwise no. Now to find the angle between vectors, you need the angle formula.
Optical charge, keep that one down. For us to write in our review sheet, if the inner product.
If X transpose Y is 0, then X is orthogonal to Y. And the orthogonal is perpendicular, so X is perpendicular to Y. And for angle, we represent angle with the symbol, the Greek letter alpha. And I always forget this formula. No, it's the angle between two vectors. Who remembers the formula? I forgot the formula. Jackson. Cosine inverse of, oh, sorry, not the angle, sorry. This is theta. Theta is the angle. The scalar multiple is alpha.
Now use alpha and beta, it's for.
So on the top, I remember X transpose Y, and I forgot the bottom. Y transpose Y? Are you sure?
Oh, it was less I. It's not I.
Not I. Okay, let me see. Come on. You have your notes, right? Did you guys have this in the note? Huh? And then what? So not this one, right? Length of X and length of Y. This one, right? Okay. See, if you have this formula in front of you, You don't have to memorize it. That means you need to know what is X transpose Y and what is length of X and length of Y means. So in formula,
No, X for.
this is length, norm of X and norm of Y on the denominator. Norm means length, okay? So X transpose Y means you are writing X row wise and Y column wise. Here, element wise multiplication. This is what X transpose Y mean. Now, what does X transpose X means? It means square root of X1 square plus X2 square plus X3 square.
Wait, that's the line, two lines on both sides of that scheme.
Right. So this is called norm. In other words, length of this vector X. So for norm of Y, it's same thing. Y1 square plus Y2 square plus Y3 square under the square root. That means all you have to do is find these three things, substitute, go to your calculator, and then it will tell you the answer.
On the test, what would you do? If we.
That's all you're doing. Bring your calculator that has an inverse function. Or at least know how to find the inverse in your calculator. Otherwise, you're stuck. So let me go about the other things.
What's the first one on everything? It adds them and takes.
It tells you what's the angle between X and Y. No.
That.
The inverse means they give you the length of a triangle and they're asking. So let's say this is your X and this is your Y.
Swap with X.
So this is telling you the length of in this triangle. They give you the length and they're asking what is this angle. So the calculator find out what is this angle by applying cosine.
Oh, the inverse.
So for E, all you have to do is know how to use calculator to find the cosine inverse. Only cosine inverse, nothing else you need. Only the cosine inverse.
For X transpose Y, when it's a 3 by 1 and a 3 by 1, we're just multiplying them across.
Mhm.
And then you just,
And okay, so let's do one of this. Let's say this one. So for X transpose Y, you're multiplying them. So you get 2 times 6, 12. So cosine inverse of 12 plus 3 times 1, 3. And then 3 times 9, 27 on the top. And then for X, it's 2 square, 1 square, 3 square. So 2 square is 4, 1 square is 1, 3 square is 9. Times, now the Y, we have 6, 3, and 9. So 6 square is 36, 3 square is 9, and 9 square is 81.
That's 12.
Where?
that's probably.
This one?
Yeah, okay.
2 times 6 is 12. Mhm.
You put all like
In the calculator. Simplify it a little bit fast so calculator will not give you anything wrong. Calculator is very sensitive, right? So for calculator, you have to put a parenthesis here on the denominator so that it understands these two on the denominator.
I have a question. Are you grading the exam or is it gonna be like this?
Right.
Okay, so if we get to this far and then we simplify it perfectly on paper, you know, we write it down, but like, let's say we make an error like in the calculation. Or calculator.
Partial
How
credit.
hard should that?
Partial credit.
But like how hard?
Um,
If we do all this, then we need to know how to.
so if I say 2 points, then I'm gonna give you 1 point.
Okay.
Yeah.
Points. How many points do you make? Yeah.
And it will be easier for me to grade if every question is 2 points. So if you get everything correct, 2. If you get something wrong, 1. Easy calculation. And then 3 points for probably
Wait.
full grade, 1 mistake and more mistake. If you have more mistake, 1 point. If you have only 1 wrong, 2 points. And if you have completely correct, then 3 points. So let's see. The next one, you're finding scalar projection. That means you need the formula for scalar projection. So scalar projection alpha. Jackson, what's the formula? X transpose Y, I remember. And then the bottom? Y transpose Y, are you sure? No, that's a vector projection. Oh, it's length of Y, right? Not Y transpose Y. Don't you have the formula in your notebook? Come on. So who has the formula in the notebook? Carl, do you have the formula? Or you don't even have the notebook? It's right formula, right? I can trust you. Okay. So write down the formula for a scalar projection. So that means you need to know what is X transpose Y and what is norm of Y.
What?
Norm of Y.
That means where everything.
Square root of Y1 square, Y2 square, and Y3 square. And norm of X means you're writing X row wise and Y column wise. So basically it's the cross multiplication. So for example, here, for this question, or X transpose Y, so we multiply -2 times 1 is -2, plus 3 times 2 is 6, plus 1 times 4, oh, maybe 1 times 4 is 4. And you're dividing by the Y square. So 1 square is 1, 2 square is 4, and 4 square is 16. So you go to the calculator and find out what is this number. Now for vector projection, I remember that. I don't know why, but I remember vector projection almost. Vector projection is represented by P. So we write projection, vector projection of X onto Y. So you're projecting X onto Y, okay? So what you are projecting onto, that has more priority. So that thing will go on the denominator, Y transpose Y, and also that thing will be the vector. And on the top, as usual, X transpose Y. So this is the vector projection. We are projecting vector X onto vector Y. So that means the new thing here is Y transpose Y. So Y transpose Y means you're writing Y row wise and then Y column wise. In other words, it's Y1 square plus Y2 square plus Y3 square. This is what it means. So for example, here in this equation, we have 1 to 4. So it's
The bottom function. Vector projecting.
1 square, I forgot the vector, 3 and 4. 2 square and 4 square without the square roots. I'm doing this question. X transpose Y, we already did that here. So let me just put it here. -2, +6, +4. So this is the coefficient. And then you're projecting this coefficient onto the vector Y. And our vector Y is 1 to 4. 1, 2, 4. That's why I put this arrow. It means write this as a vector.
Like squaring, squaring,
So our Y is 1 to 4. So the denominator gets 1 square plus 2 square plus 4 square. So the difference between Y transpose Y and the norm of Y, norm has a square root, but the transpose doesn't have the square root. It's the same thing with square root for norm, without square root for not norm.
That's not Y transpose, it's Y transpose Y. But
It means multiply y itself. So you get the same element twice. So whatever you have this coefficient, you just distribute that to each one of them, and that's your projection.
X transpose Y is like the element Y is multiplication.
Mhm.
Well, Y, you do the same thing with Y.
So you basically are multiplying y twice. So 1, 2, 4, 1, 2, 4. So 1 square, 2 square, 4 square.
But that'd be the equivalent of normal Y, where you just like square.
Almost norm. The norm, to have the norm, you have to take the square root of that thing. So norm has the square root. But without norm, there is no square root. So do you have the coefficient? Whatever coefficient do you have here, okay? You distribute to each one of them. And then that's your vector projection. So scalar projection is a number. Number. But vector projection will be a vector. It is a vector projection. A vector. Mhm.
What's the answer for the?
You give me the coefficient, I'll give you the vector. Find out what's the coefficient.
scalar projection is number, vector projection.
Will be a vector. So what is this coefficient? Simplify that. Tell me the number. So if you tell me what is that, you just have to multiply 1 by that, 2 by that, 4 by that, and you get a
Number is
vector.
0.
Denominator is not 0.
No, number.
How can numerator be 0? You have 10 minus 2. Negative 2 plus 6 plus 4. Positive 4. It's positive 4. So you get the number and then distribute, and then you get the vector. Okay. 8/20. Okay, suppose it's 8/20 if it's wrong. So 8/20 you can reduce to 4/5. So you multiply 4/5 times 1. 4/10, yeah. 4/10. 2/5, yeah. 8/21. 16 plus 1 is 17. 18, 19, 20, 21. Bora. 21. So 18/21 times 1. 18/21 times 2, which is 16/21. And then 18/21 times 4, which is 32/21. So that's the answer. So this is your P, vector projection. Now in the next question, in the next part, they're saying observe P and X minus P.
You do 16.
8. Oh, no, sorry. 7B, but I'm doing everything for 7, 8. So they said, look at the P. So we have our P. And now look at X minus P. So this is X, -2, 3, 1. And if you're minusing P, our P is this number. 8/21, 16 and 32. 16/21, 32/21. Whatever you get, okay, you will get a vector. So blah, blah, blah. You'll look at P. This is our P and X minus P, dot, dot, dot. You take their inner products, means multiply them across. If P transpose X minus P equals 0, then they are orthogonal. And in fact, the result has to be 0 because P and X minus P is always orthogonal. So if you find the result is not 0, that means something is wrong here. maybe you made it wrong in your calculation to find the P. So go back and check your P.
X minus B should always be zero.
P transpose X minus P. Their inner product always has to be 0. If it's not, that means something is wrong with your P or your X minus P. Most likely something is wrong with your P. So go back and check your P. Go back all this calculation and see, did you make any mistake?
So then it has to be orthogonal.
Or, mhm,
So if it's not, then it is orthogonal.
right.
Oh.
So it will ask actually verify. Verify that P and X minus P are orthogonal. So how do you verify? By the inner products. And then this question. So here, write down all the steps. First, find alpha for scalar projection. What's the formula? All of this. Then for vector projection, this is the formula. How to find each element? All of this. And then how do you know P and X minus P are orthogonal? The inner products. Look at the inner products. So write down all these steps. So in the exam, all you have to do is look at the steps and do the calculation. That's it. Just do not put any example. Exactly. So previously, I was actually allowing students to put examples, and guess what they did? Can you guess? Exactly. They printed out the entire review sheet. I know, you have no idea how that made me, like, how angry that made me. Like, I learned my lesson. So I was like, no, no more.
Honestly.
And it was in statistic. In statistic, they're allowed to bring a formula sheet or cheat sheet. It's actually called cheat sheet. Statistic. Statistic 213. I took 213. So they're allowed to bring that. So it was allowed. And I said, put anything. Like, example is fine, no problem. Because I never thought about like bringing the entire review sheet.
That's valid though. It makes sense. Anything error.
Exactly. Like I couldn't tell them anything because I wasn't specified enough. You cannot do this, cannot do that. I was like, oh man, like how smart are they? And then once I said, you can bring any size, like the standard size doesn't have to be standard size, could be any size. Guess what one student did? She brought the big, big poster size. She seriously, she bought a big poster.
So wait, is it 1
Entire
8.5 by
poster.
11 that you're allowed? One.
Standard size.
I think they're allowed, they
Back-
was,
back
still brings the
and
whole poster.
Wait, they bring poster, two-sided poster for final exam. Because it was final exam. And then I always collect the review sheet, the formula sheet. So I had to collect this entire big review sheet.
Not only they brought a poster, but it was two-sided.
Two-sided poster.
They might as well just bring the whole textbook with it.
Exactly. So people learn from their mistakes. So when you're not specific enough, you can always find some students that outsmart you, like, wow.
Good for them.
Exactly. From them, I learned my mistake. Actually, they didn't.
It's so embarrassing.
Because you know how picky I am. If you don't show work, don't expect to see any points.
How do you not show work?
Yeah.
Neither they.
So yeah, guys, it doesn't matter how smart you are and you do everything on the calculator. If I don't see your work, don't expect to get points from me. Okay. Okay, the next one. One of these will be in the exam. So let me do the fraction one. It may sound hard, but actually it's not bad.
So first of all, the calculator that we're bringing is scientific.
It has to be scientific.
Two
Two-sided.
Am I only using a calculator for cosine questions, or am I using it for everything?
It depends.
Do you want to keep it in practice format or?
No, fraction, I love fraction, so keep the fraction. You don't need decimal.
How, it's a limited calculator use. So it's a good question.
Most of them, you don't need the calculator. Yeah. And for cosine, if you don't want to get full points, you can just put cosine inverse of simplified version of the inside.
Is there a way to use a scientific calculator to check any answer? No, right?
Hmm?
I use a calculator to check an answer that I.
So any scientific calculator is fine. You can do anything on the scientific calculator. It's fine.
If you, does the scientific calculator do anything like that? No, no,
Uh,
really.
they don't allow graphing calculator because in the graphing calculator, you can find the reduced echelon form without doing anything.
You could-
They'll do that for you.
you could-
Yeah. Actually, in my other class, my earlier class, I had a student who bought a calculator. And guess what? I check calculators. Did you notice that I always check calculators? So I was checking his calculators and I found 2 cheat sheets inside his calculator. And I was like, what is this? He was like, I don't know how to use calculator, so I wrote down all the steps for each question. I was like, wow. So I said, bring calculator. I didn't specify. There is no cheat sheet with the calculator. So he bought his cheat sheet for the calculator.
You can specify what not to bring. Is that like, is that normal?
I don't even know what to specify not to bring until I see something bad. So see,
Fine.
like they always find, students are so smart. They always find something. Okay, so here. So step 1, you're going to find a vector v. Not find, you're going to write a vector v out of your point. So your point is 4, 5. So 4 and 5 in vectored form. This is your one vector, first vector. This is you're going to project. Project onto what? Project onto another vector w. They didn't give you any w vector. So where from we find it? Well, we have to make the w vector. How do we make it? We take the equation. So y equals 2/3 of x. Let's say x is 3. You can take any x value. When x is 3, this becomes 2/3 of the 3. 3 cancel out, our y is 2. That will become our w vector.
I forgot I have to like get a bracket by itself. Thank you.
Substitute anything that is the multiples of the denominator.
Okay.
So we found 2 vectors. Now all you have to do is project. Project your v vector onto your w vector. So you are projecting the point onto the equation. Equation tells us a vector, gives us a vector. So you're projecting the point onto the vector. So we are projecting onto that. That means that has more priority. So it will go on the denominator and it will be the vector. So in the denominator, we are going to have W transpose W, and we are going to have the W vector. So this is the vector symbol, vector. Mhm.
For W, you put 3/2. Is the 3 supposed to be the value of x? The majority?
So this is X and this is Y. Same thing here. This is X and this is Y. So X and Y, and we have X and Y.
When you're solving for a variable that's not given, you can make x value whatever you want.
During
You can say X is 6, so it will be 2 times 2, 4. Y will be 4. Like I'm picking anything that is multiples of 3 so that I don't have to deal with fraction. And then on the top, what goes on the top? Their inner product, so V transpose W. So on the top, everything has on the top the inner product. And the bottom, depending on what you're finding, we have different denominators, different everything.
projection,
So projection, remember, whatever you're projecting onto, that has more things. Like you're projecting onto W, so denominator is W, and the vector is W.
We're gonna find about
Vector.
like,
It's a vector. So it's not the number W or point W, it's a vector W, the column vector W. So let's do all the math. So let me write this way. Our V is 4, 5, and our W is 3, 2. So inner product basically means cross multiplication. So we have 4 times 3, 12, and then 5 times 2, 10. W transpose W means W square. So 3 square is 9, 2 square is 4. This is the coefficient, and we are applying this coefficient to the W vector, which is 3, 2. So we have 22 over 13 and 3, 2. So we have 66 over 13 and 44 over 13.
I think it's supposed to, 12, right?
Right. 12 plus 10 is 22. So the answer they are looking for the closest point. Closest point. You write this projection as a point format. 66, 13, comma, 44, 13. That's your final answer.
Can you give much on why or how you know that it was projecting onto W?
So let me show you the picture. It's moving on its own. It's like dancing. It gets so tired that it's want to dance. Okay, so this is the story. What is happening here? We have a 0.45. So 1, 2, 3, 4. 1, 2, 3, 4, 5. Here. This is the 0.45. And you have an equation y equals 2/3 of x. So y equals 2/3 of x, let's say somewhere here. Y equals 2/3 of x. Now they're saying on this line, which point is the closest one to this point? Is it here, 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 or here, here, here? Which point is the closest one to here? So what we are doing in matrix algebra, we are creating a vector out of this point, and then you're projecting,
Always unique.
we always create the vector from origin. And then you're projecting a light onto this. So when you project a light, it creates a shadow on this line. That shadow will tell us what is the closest point. So this is the projection. So what you're projecting, the point onto the equation. What is this point? We created vector B out of the point. And from the equation, what did we get? Vector W. That means we are projecting vector B onto vector W. Or if you want, you can say we are projecting X vector onto the Y vector.
What's the point?
Mhm.
How do we get the point?
This projection will tell you the location here.
But where in the work? We get the point.
Here. All these things. So what we did, see, this equation is an equation, it's not a vector. So first we get a vector on this equation, on this line. So we create this vector here. This is the W vector on the equation line. And then you're projecting the V vector. So this point is the V vector. We are projecting this V vector onto the W vector and see where do these projection vector land. So this projection vector land here, what's the location? 66, 13, 44, 13. 66, 13 is the X value, 44, 13 is the Y value. So that's the story we are doing here.
Are you, I don't know.
Yeah.
Pretty much like, from the question, the point that you get from the question, is one variable, and then the one that you're solving for would be.
The projection
priority.
onto.
Yeah, the priority. It'll always be the one that we find.
Mhm. So on your formula sheet, you can write down all the steps. Step 1, write a formula write a vector out of points. Step 2, write a vector from the equation by picking an x value, solving for y. Step 3, find the projection, the points onto the equation. What's the formula? Use the formula, and you get a vector. So x is the x value, y is the y value as the points. Okay, and then the last one, find eigenvalue, eigenspace with eigenvectors. So there will be one. Most likely 3 by 3. Okay. Let's see this one. I'll give something easier. So we have step 1. You need to find what is A minus lambda I. Step 2, we are going to set the determinant of A minus lambda I equals 0, and then solve for lambda. Lambda is eigenvalue. Step 3, eigenvalue. Yeah. I know how to find everything, but if you ask me meaning, I'm not interested in that. Yeah. Plus also in class, I showed a video about these things. Okay, so once you find your eigenvalue, then you need to find your eigenvector. So you substitute lambda equals to whatever value you have into A minus lambda I times V equals 0. And then you solve for V. What is V? V is x1, x2, x3. Because we have 3 by 3. This V is the eigenvector. So if you find eigenvalue, eigenvector, your eigenspace, step 4, eigenspace, you write down it's a span of V1, and then if you have more vectors, V2, all these things. So eigenvector is actually the null space of this matrix A minus lambda I. So how do you solve it? That's the way we solve null space question. You're going to solve that exactly same way. So let's do example, this one. But actually, I have the solution. Let me just go over the solution, which will be easier because we don't have time. Solution. Final exam review solution. So okay, this question. So step 1. Come on, I hate this. What's some of this? Is find A minus lambda I. How do you find it? All you have to do is subtract lambda from each diagonal of your A matrix. So 0 minus lambda is negative lambda. 0 minus lambda is negative lambda. 0 minus lambda is negative lambda. So only the diagonal change, everything else stays same as A. That's how you find A minus lambda I. And then step 2, finding, why can't I spell okay, pen? Step 3, find the determinant that equals to 0, solve for lambda. So if you look at the determinant, this is actually a triangular matrix. So its determinant is highlight. A determinant is the diagonal, right? The product of the diagonal. So negative lambda times negative lambda times negative lambda. So give you lambda equals 0. Once you have your lambda, then you put this lambda back into a minus lambda I, and then you need to solve for your variable. So a times x or variable b equals 0, and then you're looking for the null space. So to find the null space, you put the matrix and then zeros, and then you solve it. Here it's already solved, but there is nothing to solve. So this is telling us x2 is 0 and x3 is 0. So x2 and x3 are fixed. There is no information about x1. So x1 is a free variable. So you write x1 is x1, x2 is 0, x3 is 0, and they will tell you the vector we get. So basically the vector is a coefficient for all of these. So v1 is 1 here, v2 is 0 here, v3 is 0 here. So this is your eigenvector for the eigenvalue 0. So what is eigenspace? It's the span of this vector. And that's all you have to do. So I posted a solution. Take a look at all these solutions. If you have time, practice them. It will be easier. So I told you what will be in the exam, and I told you the formula sheet. Write any notes that will help you to solve it, but do not do any example. And I'll see who come up with what weird things this time. So I'll be more specific next time. So, huh? Huh? Two-sided, double-sided. One page, two-sided. One page means one page, right? Not one side. One side means one side. One page means double-sided. Right? In,
One page.
so one page. So when you say, give me a page, when someone says, give me a page, do you give one side? You give the entire page, right? So one page means double-sided. So double-sided.
Page double-sided.
Yeah, one page double-sided. Standard page, no poster page, okay? Standard page.
You what?
Yeah. So who cannot take it, they'll email me what time you can take it at Baro. And for rest of you, your exam is day after tomorrow, Wednesday, 5:20 here. Okay? So thank you for your wonderful class, guys. Thank you for your cooperation. Thank you for your understanding. Good luck.
Review sheet 3. So we started today's review at like number 4, so
4, yeah. So definitely 4 will be in the exam.
what about 1, 2, 3?
3 and 4 are the same.
Oh, okay, so.
And 1, 2 is different. Yeah, 1, right?
Also, what time available, I guess, for me to come in on Monday?
Anytime from 1.